Excellent, Sakun. And today, now we'll be discussing another chapter 2, which is the dynamics from the ES physics. As we have already discussed this in your O levels, but something is extended and a surprise for you guys. So, okay, now just understand what after. So, we'll be discussing momentum and Newton's law of motion. So, the you are already familiar with the Newton's law of motion and understanding the momentum, which is newly added by the Cambridge International in your O levels. So they are the Newton's first law, second law, and third law. The first law is also known as the law of inertia. An object will remain at rest or traveling at a constant velocity until and unless it experiences a resultant force. If an object is on the rest, so it will remain on the rest until and unless I applied any force on that particular object. Okay, and it will be stay moving in the position and will continue moving until and unless I exert any force to stop that moving object. The second law of motion describes, also known as the law of acceleration, is the acceleration of an object is proportional to the resultant force experienced by the object. F is equals to ma. Your F is equals to resultant force, m is equals to the mass, and a is equals to acceleration. It is important to note that the resultant force and acceleration are always in the same direction. And the third law is also known as the action and reaction. For each force experienced by an object, the object exerts an equal and opposite force. Meanwhile, if I keep a book on the desk, so the book is having a pressure in the direction of the desk, and the desk will also have a pressure on the book. So these are the equal pressure but in the opposite direction. The mass of an object is the property of a body and is measured of its resistance to acceleration. The larger the mass of an object, the smaller the acceleration it experiences for a given resultant force experienced. This can be demonstrated by considering Newton's second law of motion, which is F is equals to ma. Okay. For example, object 1 has a mass of 1 kg and object 2 has a mass of 10 kg, and they both experience a resultant force of 10 Newton. So A is equals to F upon M. Do not be shocked because F is equals to ma, so just derive the formula. Okay, and now object 1 is equals to, what is the force? 10 Newton upon mass 1. So it will be 10 meter per second square, and the object 2 will be face the acceleration of 1 meter per second square. It means that the acceleration of object 1 is more than object 2. Alright. It means, as you can see, the object with larger mass, object 2, will experience a smaller acceleration for a given resultant force of 10 Newton. Obviously, it is understandable because when there is a fat person, or we can say an elephant, and there is a horse, so it is more complicated for you to just push the elephant, or is complicated for you to just push the horse. Obviously horse, because elephant is having more mass, so it is difficult to accelerate or change the speed or increase the speed of uh, the particular elephant or object with a more mass. Obviously, so that's why acceleration is inversely proportional to mass. If mass is more, low acceleration. If mass is less, so more acceleration. Linear momentum is the product of mass and velocity of an object. Momentum is equals to mv, or mass multiplied by velocity. Newton's second law states F is equals to ma, therefore F is equals to mv upon t, because now you can see that momentum is equals to mass multiplied by velocity. All right, here the F is equals to delta mv, means now the momentum upon time. Delta momentum upon time, as acceleration is equals to delta velocity upon delta t, or the change in velocity upon change in time. It means that force is equals to change in momentum upon change in time. So now just forgot the formula of F is equals to ma in your A levels. This formula is essential for you. F is equals to delta momentum upon delta time. From this you can see that force is the rate of change of momentum. Non-uniform motion, the weight of an object is the gravitational force experienced by it and varies depending on the strength of the gravitational field the object is in. The weight of an object, the weight of a body on Earth can be calculated by the finding the product of its mass and gravity, the acceleration due to the gravity. Weight is equals to mg. All right. Now, okay. A body falling in a uniform gravitational field will experience a constant weight as the strength of a uniform gravitational field strength is constant. Below is a description of the motion of an object with an initial velocity of 0 meter per second in a uniform gravitational field. The object experiences weight downwards and air resistance upwards. As the magnitude of weight is larger than air resistance, it will accelerate downwards as there is a resultant force Newton's second law. As the object's velocity increases, the magnitude of the air resistance increases. Therefore, the resultant force and acceleration downwards will decrease. Air resistance will continue increasing up until the point where the magnitude of weight and air resistance is equal as there is no resultant force. The object travels a constant velocity known as the terminal velocity. All right. The terminal velocity is the velocity you will be understanding, such as in the acceleration due to the gravity. When you can take an example of a person parachute. If a person opens the parachute, first of all, the velocity will be increase. All right. Sorry, the velocity will be decrease when a person jumps from the airplane. So obviously the velocity is increasing continuously when he'll be opening the parachute. So it is not. Wait a minute. All right. So where were we? Okay. We were taking the example of a parachute. Yes. When a person opens the parachute, when he is jumping from the airplane, the velocity increases. When he opened the parachute, it is not easier to understand that the velocity will be stop or the velocity will be constant. No, there will be a decreasing velocity. Velocity will decrease. I know that the speed will decrease, and a person speed without parachute was increasing. Now with the opening of parachute, it means that it will be decreasing the velocity. And when at the time when the velocity will be constant, our velocity will neither increase nor decrease, because now the parachute is in the same direction, and once it comes towards its terminal velocity, and then will be landing on the land safely. The terminal velocity is always measured in the air resistance, or we can say in the acceleration due to the gravity. Okay, so you can just take an example of a parachute to understand the terminal velocity. All right. So the terminal velocity is the velocity when the increasing or when the velocity was increasing, and when the person opened the parachute, the velocity will decrease, but will not stop or become zero. There must be any velocity, but will be constant. The constant is known as the terminal velocity, as you can see from the diagram as well. Air resistance will affect both the vertical and horizontal components of a projectile motion, as shown in the diagram below. This is the projectile motion. As you can see, with air resistance, the maximum height is reached earlier, and the vertical and horizontal distance traveled decreases. That with air resistance and without air resistance, you can see in the projectile motion clearly what is given to you. The linear momentum and its conservation. The principle of conservation of momentum states that momentum is always conserved in any interaction with where no external forces act. This means the momentum before an event, for example, before a collision, is equal to the momentum after the collision. This fact is used to find the velocity of objects after collision. Now just see, now just clearly, for example, a car with a mass of 500 kilogram and a velocity of 4 meter per second collides with a stationary truck with a mass of 1500 kilogram. The two vehicles join together and move on with a velocity v. Find the value of v. Alright, first find the momentum before the collision. As you can see that red, now before the collision has been shown to you that block, I'll just say the block. Okay, so the red car is having 500 gram, kilogram, and the blue car is having 1500 kilogram mass. Where you can see the velocity of obviously blue one is 0 because it is on the stationary or at the rest, and of red car is 4 meter per second. And after the collision you're required to just find out the v or the velocity, and obviously you have to combine the masses. Okay, first find the momentum before the collision. So how to find the momentum? As I already told you, mass multiplied by velocity. Total momentum before collision is 500 multiplied by 4 for the red car mv plus blue car mv, means 500 1500 kilogram mass multiplied by 0 velocity is equals to 2000 kilogram meter per second. Kilogram meter per second means the SI unit of momentum. This will be discussing by the SI base unit derivation in the next video. Total momentum before collision is equals to total momentum after collision. It means that 20 will be multiplied by V. Alright. Before collision, the momentum was 2000 kilogram meter per second. After collision, it will be 2000 meter per second, kilogram meter per second. So 2000 is equals to 2000. It will be cancelled out and will be 1. Velocity is equals to 1 meter per second. Okay. There are two types of collision: elastic, where both momentum and kinetic energy are conserved; inelastic, where only momentum is conserved while some of the kinetic energy other forms such as heat, sound, gravitational potential, and may be larger or smaller after the collision. For a perfectly elastic collision, the relative speed of approach before the collision is equal to the relative speed of separation after the collision. For example, consider two steel balls of equal mass. One is at the rest and other is traveling at the velocity of v. The moving ball collides with the ball which is at the rest and transfers all its momentum and kinetic energy to it. This means that the ball, which was at rest, will now move away from the other steel ball, which come to the rest after the collision. Okay, so just wait a minute. Alright, so just quickly completing it at the last. For example, consider, okay, this means that the ball which was at rest will now move away from the other steel ball which came to the rest after the collision at a velocity equal to the relative speed of approach. Most collisions are inelastic, meaning the kinetic energy is not conserved, obviously. For example, in a collision between two vehicles, kinetic energy is converted into elastic potential energy and thermal energy through the deformation of crumple zones and also sound energies. Also, the diagram of pink and blue balls, okay, that how the velocity has been transferred when they collides. Now the blue ball is having 0 meter per second velocity and the pink ball is having the v meter per second velocity, whatever was the velocity of blue before the collision. So that's all, and I hope so that you understand. Moving we'll be also discussing the video later. Until that, it's here, and I hope so that you like it. Do not forget to subscribe and click the bell icon and stay tuned for the upcoming live sessions. Till then, take care.